All right, in this part, we're going to take a closer look at 5 commonly used layouts. And the first one is linear layouts. So if you recall, a linear layout is a view group that arranges its subviews in a linear fashion, either vertically or horizontally. And when using linear layouts, there are 3 important and mandatory properties. And the first two are layout width and layout height. So as the name implies, they specify the width and height for linear layouts. And actually, these two properties are mandatory for all views and all the view groups and the layouts in your application. And you can see that, on the slide, these two properties are set to match parent. So that means this linear layout is going to be as wide and as tall as its parent view or parent window. And a third mandatory property for linear layout is orientation. So given the orientation, as mentioned earlier, a linear layout is going to arrange its subview either vertically or horizontally. Okay, and so now you might be wondering how we can use the linear layouts in an Android Studio project in an app. So now I'm going to use my Android Studio to show you how to use the linear layouts in a project. So here I'm going to open a new project, and I'm going to name the project Layout Demo. Okay. So now the Gradle is going to compile or build this project for the first time. So please bear with me for a few minutes. I'm using a pretty old computer. Sorry about that, because I don't have money to buy a new one. Feel free to donate me if you like. Okay, just kidding. So let me open a layout file. Okay. So every time you create a new project, the default layout is always going to be the constraint layout, and you can see that here inside component tree, and you can also see that in the code mode. Okay, you can see here is the constraint layout. So how can we change the constraint layout to linear layout? It's very simple. We simply modify the string to linear layout. Okay, and you can see as I change the starting element to linear layout, the layout editor automatically changes the ending element to linear layout for me. Okay, which is pretty neat, right? And one thing I would like to mention that we cannot, okay, we cannot change constraint layout to linear layout in design mode. Okay, it can only be done in the code mode. Okay, as far as I know, it's impossible to do it in the design mode. So now I'm going to delete the text view here because it's not needed. And recall, oh, by the way, you can see that the layout width and the layout height properties are already here, okay? Because, these two properties are mandatory for all the views, all the layouts, and all the view groups. Without these two properties, the application framework cannot determine the size of the layout. So that's why these two properties are mandatory for all the views, for all the layouts. So now recall that we need another mandatory property, which is orientation, right? So let me set it to vertical, okay? So now I'm going to switch back to the design mode and add 3 buttons to the linear layout, okay? Because that's easier, okay? It's going to save me, typing for a few words. So 3 buttons, okay? So now you can see because we set the orientation of a linear layout to vertical, so that's why these 3 buttons are placed vertically, okay, from top to bottom, okay. we are still far away from the real bottom of here because we only have 3 buttons on the screen. But anyway, and now you might be wondering why these 3 buttons are so wide. They are as wide as the linear layout, and that's because you can see that their layout width property is set to match parent. Okay, again, match parent simply means making the button or making the view as wide as its parent. So that's why these 3 buttons are so fat. They are so wide. So we can change match parent. If you don't like them to be this wide, you can change match parent to wrap content. Okay, so wrap content simply means simply make the button or make the view wide enough to display its content. Okay, let me do this for all the 3 buttons. So back to the design mode, you can see that these 3 buttons are much smaller, okay, and look nicer actually. And here, before moving on, I would like to show you another useful property, which is gravity, okay? So gravity simply means you setting the force of gravity inside the linear layout, okay? So suppose you would like to, move the 3 buttons to the center of the screen, okay? So if you wanted to do so, we can set the gravity to center, okay? So now back to design mode, you can see that these 3 buttons are moved to the center of the screen, okay? As a stack, okay? From still vertically, they are still placed in a linear fashion vertically from top to down, but they are now at the center of the screen. So, and this property, gravity, also applies to other layouts as well. Okay, and one more thing I would like to add over here, you can also choose to configure the properties of a view or a layout using the attribute window on the right hand side over here in the design mode. Okay, but as you can see, there are so many different properties. Okay, and looking for a specific property using the attribute window is kind of troublesome. Of course, you can use the search box over here, but you still need to type the name of the property. And if you need to configure multiple properties, then you are going to perform the search for multiple times. Okay, and I think that's pretty time consuming. So my personal preference is to do it in the code mode, okay, using XML. That's much easier, okay? So now, before moving on to the second layout, I would like to go back to the slide and explain the difference between padding and margin, okay? So margin simply means the distance or space between the border of your view and its parent view or parent layout, okay? And in contrast, padding means the distance or space between the content and the border of your view or layout. So for example, suppose, let me delete the drawing over here, okay? Suppose this is the border of your view, okay? Suppose this is the border of your view. So margin means the distance between the border of your view and its parent layout. So the border is this, the gray area, okay? The gray area is the margin, okay? And by definition, padding, okay? Padding is the distance between the content and the border of your view. So because this is the border of view, and suppose this is the content, okay, sitting at the center over here. The margin is the yellow area, okay, on the slide. on the slide. So that's the difference between margin and padding, okay? Okay, so the next layout is relative layout. And if you recall, I don't remember if I mentioned relative layout before, but a relative layout is used for screen designs that require control elements to be positioned in relation to one another. So basically, relative layout lets child views specify their position relative to the parent view or to each other specified by their IDs. So we can align two views by right border or make one below another or centered in the screen, center to the left, and so on and so forth. And by default, all the child views are drawn at the top left corner of the layout. So we must explicitly define the position of each view using the various layout properties. And the layout properties, there are so many layout properties that we can use, and this slide simply shows some of them. And so I encourage you to look them up on developers.android.com. Okay, so here's a very simple example. So you can see that the root element here is a relative layout. Okay, it's a relative layout. And you can see that its layout width and layout height are both set to match parent. So this means the relative layout is going to be as wide and as tall as its parent, which is the window, okay, which is the entire screen. And you can see there are three child views, and the first one is a edit text window for gathering text input from the user. And you might be wondering why the edit text window is placed at the center of the screen and why it is so wide, okay? So this is because you can see its layout width, okay? It's set to match parent. So this makes this edit text window as wide as the relative layout. And in addition, you can see its layout height is set to wrap content. So this simply means the edit text window is only tall enough. Okay, it's only tall enough to display its content, which is reminder me. Okay, the string reminder me. And it's placed at the center of the screen because, you know, you can see there's a property over here, which is called layout center in parent. Okay, so this means placing the edit text window at the center of its parent, which is the relative layout. So that's why the edit text window is placed at the center of the screen, at the center of the relative layout. Okay. So now next child view is the button, this one, the cancel button, okay? So you might be wondering why the cancel button is placed, you know, over here, okay? And this is because it is placed over here because it has two properties set. The first one is layout below, okay? So layout below simply means placing this button below this guy, okay? This is the anchor view that we just talked about, okay? So, and this guy, this anchor view happens to be this one, the edit text window, okay? So that's why the cancel button is placed below the edit text window over here, okay? So this property layout below determines the vertical position of the cancel button. So how about the horizontal position? Well, the horizontal position is determined by this property, layout align parent right. So layout align parent right simply means align the right edge, okay, the right edge of the cancel button to the right border of the parent, which is the relative layout. Okay, so that's why the cancel button is placed over here below the edit text window and then right next to the right border of the relative layout. And the third chart view here is the OK button. Okay, so you can see it also has its layout below property set to this guy. Okay, so that's why the OK button is also placed below the edit text window. And now you can see there's a interesting property, layout to the left of. Okay, so this property simply means placing this button to the left of this guy. Okay, and this guy happens to be the cancel button. Okay, so that's why the OK button is placed, below the edit text window and to the left of the cancel button. Okay, so that's why this layout, okay, looks like this. Okay, very simple, right? The third layout is frame layout, and a frame layout is designed to black out an area on the screen to display a single item. And generally, frame layouts should be used to hold a single child view because it can be difficult to organize child views in a way that's scalable to different screen sizes without the children overlapping each other. So in a frame layout, child views are drawn in a stack. So this means the most recently added child on the top. And so here's a very simple example. So you can see we have a frame layout, okay, as the root element of this layout. And you can see there are two child views. The first one is an image view, okay, sitting at the center of the screen. And the second child view here, which shows frame demo on top of the image view. And the text view is displayed on top of the image view is because, as mentioned earlier, in a frame layout, the most recently added child views is going to be drawn on top of the earlier ones. The next layout is grid layout. Grid layout places its child views in a rectangular grid, and child views can occupy one or more continuous cells as defined by their layout parameters. A child view can also specify the row and the column indices of the cell it wishes to occupy, and in case it doesn't specify the cell location, the grid layout assigns a cell location automatically using its orientation, row count, and column count properties. So here is an example layout file for a calculator app. And you can see that the root element is obviously a grid layout. And this grid layout has 6 rows and 4 columns defined by the row count and column count properties over here. Okay. And this grid is filled row by row because its orientation is set to horizontal over here. Okay. So now you might be wondering why the text view of here is so big. This is because its layout column span property over here is set to 4. So this means this cell is going, or this entry or this view is going to span across the 4 columns. Okay, and in order to make the text view to fill the entire space, its layout gravity is also set to fill. Okay, and the rest of the layout file is pretty similar, so I'm not going to elaborate further. But one thing I would like to add is, in my own opinion, uh, uh, the grid layout uses a very strange algorithm for determining the widths for columns and the height for rows. So that means sometimes a column can be wider than the others, or a row can be taller than the others. Okay, so in case you want all the columns to have the same width, or all the rows to have the same height, we can simply give them an equal weight by using the layout column weight property, such as shown up here. Okay, just give them an equal weight. Or we can also use a layout row weight property to have all the rows to share the same height. So the final layout is constraint layout. Constraint layout is a very, very powerful layout that allows us to create large and complex layouts without relying on nested view groups. And because all of its power can be easily accessible from the layout editor's toolbar, I usually work in the design mode instead of editing the XML file when working with constraint layouts. So in constraint layout, a child view's position is determined by the constraints associated with it. A constraint can be a connection or alignment to another view, the parent layout, or invisible guidelines or barriers, as you will see later. And each constraint defines a child view's position along either the vertical or horizontal axis. So this means that each child view must have a minimum of one constraint for each axis, okay? But usually more constraints are needed, okay, to determine the location and the size of a child view. So now I'm switching to Android Studio to show you how to work with constraint layouts. So here's Android Studio, and I'm going to delete all the buttons that we added earlier. And I'm also going to change the linear layout back to constraint layouts. Okay, and I'm also going to switch to the design mode, okay? So now I'm going to add a button. You can add any view. It doesn't have to be a button, okay, to the constraint layout, okay? So you can see that when we add a view into the layout editor, you can see it stays where we leave it, even if there's no constraints associated with it, right? However, this is only to make editing easier, okay? If a view has no constraints, it will be displayed at position 0, 0, meaning the upper left corner at runtime. So to set up a constraint, we can drag from one of these circles to another anchor point, okay? And these 4 circles on the 4 edges of the button are called constraint handles, okay? So for example, I can set up a constraint to the upper boundary of the layout of the constraint layouts, okay? Alternatively, instead of using the constraint handle, we can also set up constraints using the constraint widget over here, okay? For example, by clicking the plus sign over here, I can set up a constraint to the right border of the layout, okay? And to delete a constraint, we can simply click on the constraint to select it and then hit the delete button, okay? We can also delete a constraint by clicking, by using the constraint widget, okay, by clicking the X or cross sign over here, okay, to delete it. Now, we can also use constraints to achieve different types of layout behaviors, okay? For example, we can constrain or specify the relative order of child views, okay? So now let me add a few more buttons, okay? So now you can see that by, adding a constraint, okay, like this. So this button is now constrained to the right-hand side of this button, okay? And similarly, I can set up constraints, okay, here. So now this button over here is constrained to the bottom side of this button, Okay, so basically we can use constraint to specify the relative order or relative locations of the child views inside a constraint layout. We can also make child views align with each other. So let me clear all the constraints. By the way, you can clear all the constraints by clicking this button on the toolbar, okay? So now I can have these three buttons to align on their left edges, okay? So this can be done by selecting these three buttons and then click on this align button on the toolbar and then select left edges. Okay, so now these three buttons are going to align on their left edges, okay? And of course, we can also have them align on the right edges or centered on the screen, for example, okay, using this align button on the toolbar. Next, suppose you have, two text views. So now I'm going to delete all the buttons, and now I'm going to add two text views to the layout. So suppose you want to align the baseline of these two text views. How can we do that? Well, it's very simple. Simply right-click on one of the text views. Okay, right-click on one of the text views and select Show Baselines. Okay, and then drag from this baseline to the baseline of the other text views. So now these two text views are going to align. The baselines of these two text views are going to align with each other, okay? Very simple. So now, as mentioned earlier, we can also constrain a view to guideline. A guideline is simply an invisible line. It can be vertical or horizontal. And to create a guideline in constraint layout, we simply click on this button on the toolbar. Okay, this is called the guidelines button. Okay, so we can create vertical guidelines or horizontal guidelines. So in this demonstration, I'm going to create a horizontal one. Okay, so at runtime, this guideline is actually invisible. Okay, and we can drag the guideline to reposition it and click on this circle, okay, to toggle between decimal, independent point, or percentage relative to the layout stage, okay? So now, once the guideline is set, we can constrain child views to the guideline. For example, let me add a button to a layout first. Okay, so now I can set up a constraint from the button to this guideline. Okay, it's very simple. In addition to guidelines, we can also constrain views to a barrier. Similar to guidelines, barriers are also invisible. The difference is that a barrier doesn't define its own position. Rather, its position moves based on the views contained within it. So to add a barrier, similar to how we add a guideline, to add a barrier, we also click this guidelines button on the toolbar, and you can add a vertical barrier or a horizontal barrier. So let me add a horizontal barrier. Okay, now you can see it's invisible in the layout editor even. Okay, it's because it doesn't have its own position. We have to constrain child views within the barrier in order to determine its own position. So let me add two buttons to the layout. Okay. Okay, and now to constrain these two buttons to the barrier, we have to select these two buttons and drag them to the barrier. Okay, so now you can see that these two buttons are now constrained within the barrier. Okay, and once these two buttons are constrained inside the barrier, we can change the barrier direction. Okay, using the attribute window. So you can see as I change the barrier direction, the barrier moves inside the layout editor, okay, according to the relative position of the two buttons, okay? So finally, if you have a multiple, let me delete the barriers first, okay? So if you have multiple child views along the same axis, okay, either the x-axis or y-axis, um, okay, and we can have them, for example, we can stack them or pack them vertically like this, or we can um, distribute them vertically, okay, in the layout, okay. So that's pretty much all we can do with constraint layout. You can see it's a very, very powerful layout. Now I will show you another a final trick, okay. If you are very lazy, if you want to set up constraints one by one, you can place the child views inside the layout at the locations you want, okay, for example, like this, okay. Let me delete this constraint, okay, so now there's no constraint. If you are very lazy or if you don't want to specify the constraints one by one, you can simply place the child views at the locations you want. And then once you are done, you can click this Invert Constraints button on the toolbar, okay? So the constraint layout is going to add all the necessary constraints for you to make the screen look like this at runtime for you, okay? So this is a pretty neat, feature, okay, of the layout editor. Okay, that's all I wanted to talk about layouts.